Hey, Swati here. Welcome back to Python, zero to expert. Waiting on 10 slow network calls, one after another, is agony. Concurrency lets them happen together. Today, we make your code wait smart, not hard. Module 16. Concurrency confuses a lot of people because Python gives you a few tools and they're for different jobs. So let's cut through it, which tool, for which kind of work, and what that famous GIL actually means. 3 things. You'll use async for waiting on the outside world. You'll know when to reach for multiprocesses instead. And you'll finally understand the GIL, without the fear it usually comes with. Here's the classic mistake. A waiting inside a loop looks concurrent, but it isn't. Each call finishes before the next begins. It's secretly one at a time. The fix? Start them all, then gather. Now they overlap, and 10 slow calls take about as long as one. This is the shape. An async function, an async IO gather. You hand it several tasks, and it runs them together, handing back all the results when they're done. This is your go-to for anything that spends its time waiting. Network, files, databases. And the rule that saves you. If your work is waiting, network, disk, use async. If it's heavy computation, crunching numbers, use multiprocessing, real separate processes. Why? The GIL, the Global Interpreter Lock, lets only one thread run Python at a time. So for pure CPU work, threads don't help, processes do. Sarah here. Real async code. Build one task per URL with a comprehension, then gather them all. 100 pages, fetch together in the time of the slowest one. Read it once, and async stops being scary. But gather has a trap. Ask it to run 100 fetches, and it starts all 100 at once. 100 open connections hammering one server, until you run out of sockets and calls start timing out. Picture a shop with 100 shoppers but only 5 checkout counters. You don't send all 100 to the tills, you form a queue. And at most, 5 check out at any moment. In async, that cap is a semaphore. Here's the whole pattern. Make a semaphore set to 5. That's your 5 counters. Every worker says async with sem, which quietly waits for a free slot before it runs, and hands the slot back the moment it's done. Then build 100 workers and gather them exactly like before. Same gather, same 100 tasks. But now, never more than 5 are ever in flight. This is the Python answer to Node's p-limit.
Liam, here. Quick gut check. Log how many are running and watch. Active sits at 5 the whole way, while done climbs from 0 to 100. All 100 tasks finish, but the server never sees more than 5 of you at once. That's the cap doing its job, and the difference between a scraper that's polite and one that gets you blocked.
So 3 tools, and the whole trick is matching them to the work. Async for IO-bound work with thousands of waits, like fetching 1,000 URLs all on one thread. Threads also for waiting. But when your library is blocking and isn't async aware, reading a few hundred files say the GIL steps aside while they wait. So threads overlap nicely there. And processes for CPU-bound work, real number crunching like resizing 1,000 images. Because separate processes sidestep the GIL and use every core you've got. Simple version. Waiting, reach for async or threads. Computing, reach for processes. And here's the part that ties it together. That same idea, a semaphore, exists in all 3 worlds. Async IO dot semaphore for async, threading dot semaphore for threads. Multiprocesses, semaphore for separate processes. Same counter, Same 5-slot cap. You just guard the work with async with or plain with, depending on the model. And honestly, most of the time you don't even write the semaphore yourself. A thread pool or a process pool with max workers set to 5 caps it for you. The pool size is the limit. One idea. Everywhere. And that's concurrency. Async for waiting, multiprocessing for crunching, a semaphore to cap how many run at once, and the GIL finally makes sense. Next time, the data model and memory. Names, objects, and the one that trips everyone. Is versus equals. I'm Swathi. This is Codecraft. See you there.